Okay, continuing page 157, example 3. They want us to see whether these are equivalent expressions. So, easiest thing for us to do would be to start with this expression on the left here. Using what we've talked about, we know this first expression, we've got a part here that's got a number right next to the parentheses. Means we can use our distributive property that we learned. So distributive property means we could take 6 times n and then plus 6 times 3 if we distribute the 6 there. 6 times n is the same as 6n. 6 times 3 is 18. And then we just bring down the minus 4. Like we talked about yesterday, like terms can be combined. So you guys know these are just constants here. The 18 minus 4 can be combined together is how they got the 14. 6n plus 14. We don't know what n is equal to, so we can't combine those. So we're just going to leave that as 6n plus 14. And you may notice our other expression we had to start out with was 6n plus 14. So that means that these are equivalent expressions. Okay? If we simplify and we get the same thing, they're equivalent expressions. Okay? In the book here, they're substituting a value to justify that they're equivalent. It's possible there's one value, if they weren't actually equivalent, there's one value you could substitute and it would look like they were equivalent and they actually weren't. But anyway, they put a 3 in for both of those. They got 32. Just to be safe, you could put one other number in and see what you get. Maybe put 0 in and then we'd get 14. Okay, that'd be another option, just doing testing 2 points just to make sure, or 2 values to make sure that those are equivalent to each other. Okay. On the try it, we're going to make a slight change here because we haven't talked about one of the things with this problem. So instead of 2 times the quantity x minus 3, we're going to change that quantity to x plus 3. So on this problem, just like we did on the example above, the first thing we're going to do, looking at this expression on the left, we can distribute. So that means we would be taking 2 times x and then plus 2 times 3. Again, make sure when you do that, the 2 gets multiplied to the x and to the 3. And then we just bring down the plus 1 that was at the end. So 2 times x is the same as 2x. 2 times 3 is 6. We bring down the plus 1. And then try to simplify. We're going to combine like terms that we have here. So we know the 6 and 1 are both constants. That can be combined together. So 6 plus 1 would be 7. Quick reminder. The 7 at this point would be, this would be a constant. The 7 would be a constant. And then the 2 that's next to the x, remember, is called a coefficient. Okay? Coefficient is just a number that a variable is being multiplied by. So you can see this turned out as 2x plus 7. Over here we have 2x plus 6. So those did not simplify to the same thing, so those are not equivalent. Okay, and again, we could say something about they're not equivalent because they didn't simplify to the same thing. Page 158. Let's look at the do you understand number 5. It asks if these are equivalent for any value of y. So just like what we were just doing there, we would be distributing. So we'd be doing 3 times y plus 3 times 1. So when we multiply these, 3 times y is 3y. 3 times 1 is 3. We have 3y plus 3. Our other expression was 3y plus 3, so we could say Yes. Whoops. They are equivalent because they simplify to the same expression. Let's look at the do you know how number 6. So number 6, they're just asking us to use the distributive property here. So why don't you take a minute to try to work through on 6 and 7. So on number 6, we are going to distribute. A key factor when we do these problems is to remember that we're distributing to everything in the parentheses. So the book kind of only is giving us room for an answer off to the side. That doesn't mean we can't do other work elsewhere. So I'm just going to work underneath this. So I'm going to say we would want to do 2 times r plus 2 times 3. And again, the arcs above here kind of remind me, not only do I need to multiply the 2 times r, I also need to multiply the 2 times 3. So when I do that, I know 2 times r is 2r, and then 2 times 3 is 6. So those are not like terms. I'm not going to combine them together or anything. That's going to be my answer, simplified, is 2r plus 6. On number 7, we have a 6 to distribute, so we would take 6 times 4s minus 6 times 1. So 6 times 4s, we know 6 times 4 is 24, so 6 times 4s would be 24s, and then 6 times 1 is 6. So 24s minus 6 would be our answer for that one. Number 8 is a little bit different. This is kind of backwards of what we've been doing here. Okay? So this is kind of like, it's not really a word, but I'm going to say it's like undistributing. Okay? It's really what's called factoring. We'll learn about later, but it's kind of the backwards process of distributing. So basically, we're thinking about if we had 8t plus 2, what could we have started with 2 times what quantity that would give us that. So we could think about 2 times what that would give us 8t, 2 times what that would give us 2. So in order to get the 8t, 2 times what to get 8t, we know 2 times 4 equals 8, so this would be 2 times 4t, and then 2 times 1 would give us the 2. And again, to check yourself, you could actually just distribute that out, and you should get 8t plus 2. So on workbook page 37, number 1, they want us to write equivalent expressions. So let's look at number 1. So number 1, we distribute here. We would do 5 times m minus 5 times 2, which would be 5m minus 10. So number 3 would be distributing again. To find an equivalent expression, we would do 6 times 8x plus 6 times 1. 6 times 8x would be 48x, and then 6 times 1 would be 6. And again, those are not like terms. I'm not going to combine them together. 48 plus 6 is my equivalent expression. So 7 is kind of backwards. What we're going to do looking at these, we're going to see what these have in common. So basically the 8 and the 16, we're going to try to figure out what their greatest common factor is. Okay? So the greatest common factor, the biggest number, 8 and 16, could both be divided by evenly, would be what? 8, right. Okay, so 8 is actually our greatest common factor. There are other equivalent expressions we could use, but this is probably the best way we could do this. Okay, so this is like factoring out an 8. It's kind of that backwards process again. Then we would think about 8 times what to get 8W? 8 times what to get 8W? 1W. Or you could just put W would be fine also. Okay? And then it's going to be a minus. And then 8 times what to get 16? 2. Good. So that would be our equivalent expression. Okay? Like I said, there are other things that would be equivalent. That's going to be your best answer, understand? But another possibility, you know, they do have, for example, a 2 in common. And then that would be 2 times 4W and then 2 times 8. So that would be another equivalent expression. Okay, we could have done a 4 also. All right, but that would be, the first one we did would be the best way of answering that question. If you look at number 11, they want us to write the letter or letters of the expressions that are equivalent to the given expression. So what we're going to do here basically is we're going to try to simplify these if we can. 5x plus 5, there's nothing to do there. We don't have any like terms and we don't have anything to distribute, so that one's done. If you look at A, we actually do have some x's here. We'll get into this a lot more next year, but that sign to the left goes with that term, kind of. So what we want to do, kind of rearranging a little bit here, thinking about this, 10x minus 5x, that's what we want to combine together. Okay, so just like 10 minus 5 is 5, 10x minus 5x would be 5x. And then we've got plus 5. Another way you could do to test to see if they're equivalent would be just to substitute random numbers and see if they were equal or not, okay, if you weren't sure how to simplify that. B is not going to be the same thing. That's kind of like if they looked at the 5x plus 5 and said, oh, let's combine these together. We can't do that, so that's not going to work. So A does work, B does not work, and then C, we could distribute those. That'd be 5 times x plus 5 times 1. And that would be 5x plus 5. So that would be equivalent as well. So A and C would be our answers on that one.